Hello and welcome back for another VMK in the OpenGL Tips and Tricks series. I recently posted a video tutorial in the C++ series, I think it was number 24, where I showed you how to load a PNG file. In this VMK, I'm going to show you how to use that knowledge to actually load in a PNG file into our game engine so that we can use a PNG file as a texture within our game. Our setup to load in PNG files is pretty much identical to the one that I demonstrated inside of the C++ series. However, there are going to be slight modifications, so I will be going over the modifications here. However, to go through a full explanation of how the PNG library works so that you can load in files, I recommend you view VMK number 24 in the C++ series to get a fuller explanation of the code that we're going to be using in this VMK. To start, what we need to do is have our library accessible to our game engine. So I'm going to be using the Ghost Host game engine, but you could be using the OpenGL game engine. They're basically very similar in terms of how they handle textures. I'm just going to choose to use the Ghost Host source code since I have that readily accessible to me. So first thing we do is we need to download zlib and libpng, same as I showed in the C++ VMK series. I've put them here on my hard drive under C Program Files Programming Libraries. So here's the PNG library and here's the zlib library. I set them up exactly the same way that I did back in the C++ VMK series and built everything out. The one thing that I need to point out here is by default, when you open up your PNG lib files, you'll notice that there is a setting set up that is not quite right, so it needs to be corrected. Going under the properties for libpng, make sure that under C++ code generation you have multi-threaded debug DLL selected here under the debug configuration. Under the release configuration you'll have multi-threaded DLL. By default, when you download the files and open everything up for the first time, you'll notice that the release one is set correctly, but the debug one is set to multi-threaded DLL. It's not set to multi-threaded debug DLL. If you don't make this correction, then when you try to link into this library from our game engine, you'll notice that you won't be able to read in PNG files correctly. And that's because the runtime that this library is built out is going to be using one set of libraries, whereas our game engine uses a separate library. So to make those two things match up, make sure that the debug setting here is set to multi-threaded debug DLL and the release setting here is set to multi-threaded DLL. Once you have that, build the PNG library and that will give you a debug folder and a release folder. Inside of the release folder you'll find you have your release DLL and your release library, and inside of the debug folder you'll have your debug DLL and your debug library. So those are the two files that we're going to be using inside of our game engine to be able to access all the PNG functions. Again, if you need help on how to get these files built for you, go through the C++ VMK number 24 to see how it is that we generate these files. Okay, the next step is to open up our game engine. In this case, I'm using the Ghost Host game. And in here, we can confirm that the game engine is set up to have the code generation set to multi-threaded debug DLL. And for the release configuration, we're using multi-threaded DLL. Before we do anything, we want to make sure that we can actually build and run our code. So I'm just going to build it out, run it, and see that sure enough my game engine is up and running. So what I'm going to do is add some source code to be able to load in a PNG file into memory, and we'll use that data as a texture so that we can display it onto the screen of that main menu. Okay, so let's jump into the source code. Inside of the scene library, we want to go down to scene.cpp, and in here we have something called initialize. And inside of the initialize function, this is where we're loading in textures, and then we're going to be allocating which section inside of the game we want to display those textures. So what I'm going to do is I'm going to take one of these chunks of code here, which what this does is it says I want to load in a specific texture, save it in a particular group with particular qualities, and that is all saved inside of a member variable. So we're going to go and just put this duplicate down below here, and I'll label this PNG test, and we'll create a m_png texture ID variable, which will keep track of the PNG texture file that we load into memory. We're going to use the texture manager to load in the texture, and the texture that we're going to be loading I'm going to have located here under resources textures, and the name of the file is pngtestimage.png. So we'll need to make some modifications inside of the texture manager so that we'll be able to load in a PNG file. But after we do that, then we should get back a texture ID, which we can then check to see whether it loaded correctly. If it did, then we'll return true, otherwise we'll return false. So we need to tell our scene class what this object here is. So let's open up the header file, scene.h, and in here we should see that there is a grouping of our texture IDs. So here they are here. I'm just going to add it to the top here. So it's going to be a texture ID. It's called m_png texture ID. Now doing that, we can see that a texture ID here has a constructor where we need to pass in the group and the ID. So that means that inside of our scene constructor, we need to initialize this variable, or else we're going to get our compiler complaining. As a matter of fact, if I just try to compile scene.cpp right now, we should see that error. So it says texture ID has inappropriate default constructor available. And if we click on here, it just goes into our constructor saying something's not initialized. Well, the thing that's not initialized is that new variable, so we need to specify a group. I'll just say group_1 and a ID value of 0. So now if we go and compile that, then we should see that scene.cpp compiles correctly. Now, if we were just to run this right now, as a matter of fact, let's give that a try, we'll see that it does run, however, it gives us an error message saying cannot load this PNG file because it's an unsupported image file type. So we need to go in and make some modifications to the texture manager so that we can actually load in a PNG file. So let's find where that code is. We have our load texture function here. So let's go take a look inside of load texture. Inside of here, what do? Well, we go through, we strip out the file name, we change the slashes to be in the correct direction, and then down here we initialize a texture object, and then we call the load function, passing in the file name that we want to load. So let's take a look at load. And what load does is it goes through, checks to see if there's a file extension on there, and strips out the extension, and then depending on what the extension is, decides how to load it up. So if the extension is .tga, then it calls this function called load_tga, and then it goes and calls create texture OpenGL. If it's a map file, then it loads the file, because a map file is just a TGA file with a map extension as opposed to a TGA extension, and then it doesn't actually create a texture. Instead, it saves that variable internally, so then we can use it for determining how to set up our map inside of the Ghost Toast game. Well, we want to add in an extra if statement here, so we'll just copy this one here because we do want to create a texture. And I'll put it right here. So what this is going to do is it's going to check to see what is the current extension of our file name. And because we're loading PNG files, they're going to be PNG at the end. And if that matches, then we want to load directly into the video RAM. So we're going to create a function called load PNG, passing in the file name. And then we want to create a texture OpenGL and return true if everything goes correctly, otherwise we'll return false. So we need to go and create this load PNG function call, which will do all the meaty work to actually load in a PNG file. We need to go into the declaration here for texture.h, add in a new declaration, and call it load PNG. It's going to accept a file name, and we do need them to be square, so I'm going to take out that second parameter because it's always going to be true for us. If you wanted to change this up and be a little bit smarter in terms of how to handle textures. For instance, let's say you wanted to have map files saved as either a TGA file or a PNG file. You could do that. You could basically check to see if whether the extension is a map, and then depending on the header of the actual file, if it's a TGA header, then load it using the PNG loader, otherwise load it using the PNG loader. So you could do that, but I'm not going to go that extra step to make the game engine more flexible. Instead, I'll just show you how to load a PNG file into a texture and then display that onto the screen. Okay, so we have this definition now. What's left to do is actually write this function so that we can load in an image file. Down below here is our load TGA function call. So what I'm going to do is take all of this, copy it, and modify it so that it loads our PNG files. PNG, we take in a file name. We don't need that second parameter. And up here we can say load PNG, loads a PNG file, loads a PNG file into memory, like that. Okay, so now how do we load a PNG file? Well, going back to VMK number 24 in the C++ series, we've already seen the code that we need to use to load a PNG file. I'm going to be taking that code and pasting it into here and modifying it so that all the error statements basically use the error handler, and then the very end of it is going to be slightly different because we want to actually generate a texture. Okay, so now let's take a look at the actual source code to load a PNG file. The first thing that we start off with is our PNG file structure. This is going to be the exact same structure we created before. This time we're going to be saving it inside of texture.h. So going inside of here, at the very top we see we have a TGA header and a color type. So right below here, let's add in the structure for the PNG file. Currently, our compiler doesn't know what PNG underscore struct, PNG underscore info, or any of these functions here do, because we haven't actually told the compiler about the PNG library. So we should go ahead and do that next. To do that, we need to go inside of the game engine, properties, and for the general section here, we have additional include directories. So here we want to modify this and add in our library for our PNG library. Now, the way that I did this is I created an environment variable called PNG SDK and had it point to the downloaded files, which are located right here. Inside of my environment variable, I just set up that variable to point to this directory here. So then when I try to look for instance, PNG underscore H, it's able to find these files. So after making that change, you can hit apply for the debug configuration, and you want to repeat that for the release configuration as well. Okay. Once you do that, the other thing we need to do is going back inside of the debug configuration for the linker, we also want to add in the under general, we have additional library directories. Currently this is set up for all the libraries that we're using, all except for the PNG library. So here we need to add in PNG SDK slash, and let's go find where the libraries are located. Well, that's under projects, vStudio, and for me, I have the debug and the release folder right here. So what I'm going to do is just take this and copy it over. Hit apply, and we want to do the same thing for the release configuration. Okay, and that sets up the library to be linked in, but we actually have to specify which library we want to link in. So under input here, we need to add in some parameters to actually specify what is the value. And Let's take a look back at the file name. Under the debug version, it's called libpng15.lib, so let's copy that. And under the release folder, libpng15.lib, so it's the exact same file name, just in a different location. Hit OK, hit apply, and do the same thing for debug. Okay, so that sets up our game engine. Now, we also need to make some changes here for the scene library, because the scene library will be using the header files for the PNG library, so we do need to also add in the include files here. So now, if we're just to do a build clean solution and rebuild, let's take a look at what happens. Okay, math library built correctly. The object library is complaining. So it looks like we need to add in the paths into the object library. And the scene library is going to fail as well because it relies on the object library. So let's go make that modification under Properties, C++ General. In here, we want to add in the PNG SDK. And for the release mode, same thing. Well, while I'm here, I might as well add it into the math library as well. We don't really need it, I don't think, but maybe later on, if you do change something around in terms of how the code is written, you would want to make this change anyway, so we'll save the work. We'll save ourselves doing some work later on. Okay, so let's do another build, clean solution, and rebuild. Okay, I'm still getting errors in terms of it's not able to recognize any of these, so let's see here. Oh, I set up the path, but I didn't actually tell it which file inside of that path it needs so that it can understand what these things are. So up above here, we need to go and actually specify include png.h. And now if we go do a build clean, I think this should work. Okay, so sure enough it succeeds, which means that scrolling down here now it can find what these functions do and how they should be defined because they're declared inside of the png.h file. Going back inside of texture.cpp, we now have this PNG file object, so we can use it to actually load in our image data from our PNG file. First thing we did is we tried opening up our TGA file to see whether it actually existed on the hard drive. So we're going to do the same thing with a PNG file. The way we do that is we call fopen. We use the PNG file pointer. If it succeeds, we go down below. If it fails, then we'll display an error message saying we cannot open that specific file. Next thing we did is we took a look at the header file of the file and analyzed it to make sure that it's actually a TGA file. Well, with the PNG case, we have something similar. We used our header bytes to load in the appropriate amount of data from our file pointer, and then we used the PNG_sig_compare to check to see whether this file's header file is actually a PNG file. So if it's not, we display is not a PNG file, and then we exit, returning false. So that will take care of that. Now in the TGA case, we check to see whether it was a certain type, and then we check to see what were the color bits. Well, before we get that far inside of the PNG file, we needed to set up a few things. We needed first to check to see whether the PNG library was supported by the current version of the libraries. So that's going to be checked here. And then we loaded in our info structure and we set up our error handlers. We set up our I/O structure, and then we notified the library how many bytes we already pre-read inside of the header. So that was the number of header bytes that we loaded. Okay, so now we're ready to move on and actually take a look at the contents within the image file. In the TGA case, we checked to see how many bits there were per pixel, and then depending on whether it's RGB or RGBA, where we had 24 or 32, we had an error condition here, and then we set the appropriate type. So we need to do both of these things. We need to set up the number of bits per pixels as well as the type of image that we're currently loading up. For both of those cases, we first need to read in the PNG data, transform it appropriately, and then we can take a look at the color type. If the color type is RGB, then we're going to set our type to be CT_RGB, and the number of bits per pixel is going to be 24. If our color type is RGBA, then it's going to be set to CT color type RGBA, and the bits per pixels will be 32. If it's any other color type, then we're just going to display an error message saying it's an unsupported color type. I will display the value of the color type here, and then we can return false. So that's going to take care of these steps here. Next thing we did is we figured out what's the width and our height of our image, and then did some checks to see whether the size is actually correct to be a texture within OpenGL. So the width and the height is retrieved using these two functions. We've seen that before. If the width is not equal to the height, then we'll display an error message saying cannot load this file. This PNG file is of size width by height. The size must be square. And we pass in the parameters that we had retrieved up above. If it is square, then we check to see whether the value of the width is equal to an increment of 2 to the power of something. So it has to be either a 2x2 image, 4x4, 8x8, 16x16, 32x32, or so on and so forth. So we do that check here. This is the exact same code that we used in the TGA case. And then the only difference here is that we don't have this flag b must be 2n squared, because we know that it has to be 2n squared to be a texture. So I just ripped that variable out and rewrote the code here down below. So if we fail anywhere up above, then that means that the image that we passed in is a PNG file. However, it's not the correct size or proportion. So we can take this out since we completed that work. And that leaves us down here where we actually allocate some data for the image, and then we go through the actual process of parsing the file and loading that data in and saving it inside of that variable. The first thing that we need, how many bytes there are of data per row. So we can get that from this function here. Then we can calculate what is the size of our image. So it's going to be the number of bytes per row times the height. And that's the number that tells us how large our array of pixels should be. So that's going to be all of our pixels. If this didn't allocate correctly, then we just display an error message and quit. Otherwise, we can then go through and use the PNG get rows function call to load in all the data and save it inside of this variable here. So this is a copy of all the pixels that are stored inside of our PNG library. What we want to do now is take all of these pixels and transfer them over into this member variable, since that's where we need them for our existing code to continue working. So we've basically done this, and then what we do is, depending on the way that the TGA file was structured, we load in the data. So let's let's delete all of this and say that we're basically doing this where we're loading in image data directly into here. Well, that's not exactly how we're handling things, but that's overall the operation that we're performing. So we need to take the values that are stored here and transfer them over here. We can do that with a simple for loop, where we go through the height of our data, and for every single row, take the values that we have in that row and save them inside of our array. Let me go inside of Photoshop here to show how this is working. So from the PNG library, we got a pointer to our rows, and this structure is basically a two-dimensional array of our data. So we have our data stored like this. So for every single row, we have a bunch of pixels. So here we're going to have pixel 1, pixel 2, pixel 3, and so on. And for each of these, we have RGB, or if we have alpha as well, then we have RGBA stored. And then we have the next pixel, next pixel, next pixel. So our structure is basically a two-dimensional array which tells you which row we're working with, so which one of these we are. And then the second parameter here tells us which coordinate within that row we want to get at, so which pixel. Well, we don't want a two-dimensional array, we actually want a one-dimensional array that has all of our data stored for OpenGL to be able to parse it. So all of this stuff here is what we're going to do is we're going to say, okay, starting at number 0, this is 1, this is 2, this is row 3, 4, so on. So we're going to take row 0, all these pixels, and cram them in to our array. Once row 0 is done, then we're going to take row 1 and cram it in right after it. So it's going to have all the pixels there. So this is now row 1. And then we're going to take the next row down and then cram it in right after that. So here's all the pixels for that row, so on and so forth, all the way down to the very last row where we just have all the pixel data down like this. So we're converting our two-dimensional array into our m_p, whatever it's called, for the member variable that's containing all the pixels, which we'll then use to pass into OpenGL. So let's analyze this a little closer. We're going to start at row 0. So here we're going to take all the pixels from row 0, and we're going to copy them over into our one-dimensional array at this location. So it's going to start at number of bytes per row, which is some value, multiplied by 0. So this initially is going to be set to the location at 0. And the amount of pixels that we want to copy over, well, that's the number of bytes we have per row. That tells us how wide our row is. After we copy that row, we go to the next row. So this is going to increment to 1. We're going to grab all the pixels from row 1 and copy them over to this new location, which is going to be located right after that first row inside of our array. So once we're done this, we're going to have converted over our two-dimensional array into a one-dimensional array holding all of the pixels for our image. Okay, so we've done that. TGA files flip their RGB representation inside of the file, so we needed to flip that. We don't need to do that with PNG files. And here we needed to flip the image depending on how the image was actually saved inside of the PNG file. So we can delete that. And then the last thing we had here was saving the file name. So we do need to do this. Save the file name into this member variable, and then we're going to return true. So That should take care of the case of being able to load in our PNG file. Now let's take a look at the PNG file that I'm going to be using. Back inside of Photoshop here, here's the test image that I created and I saved out as a PNG test image file. It's a little hard to see what it is because all of this stuff here is transparent. So I created this extra layer which is magenta in color so that we can see what exactly it is that this PNG file contains. And we can see that right around the very border of it, I have this 1 pixel wide white border all the way around. And then down here, I have the actual PNG test image that we're going to be using. And this size here is 200 pixels wide, 100 pixels tall. I have some text, and I have 3 splots here of red, green, and blue. Typically when I use test images, I like to have pure red, green, and blue pixels inside of the image, which we can see here. If I click on that and take a look at the RGB values up here, you see that red is 25500, green is 02550, and blue is 00255. Those are pure red, green, and blue values. I do this specifically to make sure that when I load in a texture for the first time and take a look at the output on the screen, I'm actually getting red, green, and blue. If you're not getting red, green, and blue, then that tells you that the pixel format within the file or something else is wrong in the sense that it's not giving you the correct conversion over. So if you're to do this test with the TGA file without having flipped the RGB values, you'd notice that the colors in your image would not be red, green, blue. That would be something else. That'd be like blue, green, red, because the green and red values would have been flipped. So this is the test file that I'll be using. I've taken the file, saved it out as a PNG file, and now we need to put it inside of the directory where we specified we're going to be loading it from. So if we go back to our project under Build, Resources, Textures, this is the directory where we put everything. So there's our PNG testimage.png file. And if we preview it, we can sure enough see that there's the image file. It's a little hard to see, but there's our red, green, and blue splots. Okay, so we have everything set up. Let's go and try to run our code to see what happens. Oh, wait a minute. I've actually forgot something. If we do run this right now, you'll see that it should build and start. Well, okay, there's a few bugs here. It's saying here it can't start the program because it can't find libpng15.dll. Going back inside of our project folder here under the build directory, you notice that this is where we're running from, and when we try to run our executable, it complains saying that it can't find our DLL file. The DLL file for our audio is here, but we forgot to copy it over into this directory for our PNG library. So we need to go and do that before we're able to use the library to parse a PNG file. Going back inside of here under Visual Studio, under Projects, Visual Studio, we're compiling for the debug version, so we need to take the debug library and paste it down here. Okay, so now let's give this a try. Okay, notice that we did load successfully this time. However, we don't actually see the PNG image files anywhere on the screen. Well, the reason why we don't see it is because we actually haven't placed it anywhere on the screen. I forgot to do that earlier. So going back inside of our scene, we saw that we loaded the texture into memory, but we actually haven't used the texture anywhere. Down below here, we need to have something like this. So what this does here is it says we want to add an image, and what image do we want to add? Well, we need to define a new GUID for our PNG file. So let's go and create one. I'll just put it here at the very end. I'll call it PNG test. So right here we want to replace these to PNG test. Then we want to specify where do we want to place this image. Well, we want to place it on the introductory screen or the main menu screen. So we'll copy this over, paste it here. The third parameter, that was the position. Well, let's put it at location 0, 0. And the last one here is the size of it. So to start off, let's just take the entire size. The size of the image was 256 by 256. So I'm just going to say that the size of that image is exactly that. Finally, we need to actually say which texture to use to represent this image on the screen. So here we need to specify where we want to use this guy here. And then this last parameter is where is the bottom left-hand corner of our image within the file that we just loaded. Well, it's going to be located right at the very bottom, so that's 0, 0. Okay, so now after making that change, let's do a clean and rebuild and give it a try. Okay, so that succeeded. Let's run our code and take a look. So we have our PNG file loaded, and it is actually displayed onto the screen. Though one problem that we do see here is we are getting red, green, blue, but the overall image is flipped vertically. So there is a problem. Well, the problem is that when you load in a PNG file, the PNG file is actually stored in the reverse order in which OpenGL expects the pixel data to be passed into it. So when we did the conversion here from the pixel data row by row, we need to flip this over so that the image actually shows up correctly on our screen. Now we could use the existing function that we used here to flip our image vertically. However, there's an easier way, because what this is going to do is it goes through a second time through a double for loop, switching all the pixels around. Well, we don't actually need to do that because we already have a copy of our pixels, which is here, and we're saving it inside of this guy here. So as we're saving it, let's just save it in the reverse order as opposed to the order that we're currently using, and then that's going to automatically flip our image for us. So to do that, instead of using R here, we would want to start with the last row saved first. So here we're going to start at R equals 0. Well, instead of using R equals 0 here, we want to use the last row, which is going to be equal to the height minus 1, that's the last row, and then as we increment, every time we go to the next row, we want to go to the previous row like so. So that's going to do the flipping for us. Now if we compile and run our code, we see that our image is flipped correctly and is being displayed on the screen correctly. The other thing we can confirm here is that we do have transparency, so we can see as I move this over an image, we can see through those pixels to the underside, so the transparent value of our texture is actually getting saved correctly. And if we didn't want the entire image like it is here, we can go through and crop that out by specifying a smaller size here. So we said that our image was 200 by 100. If we do this and run our code, we see now that we only get that section of the image. Now notice that the very top of our image is cropped off, which tells me that there's either a sizing problem or there's a bug inside of the texture manager. So if we change this to be 201 and run it, we see that it does display correctly onto the screen. So there's probably a bug somewhere in terms of how it transforms the coordinates, the texture coordinates, to specify what are these corners of the actual image that we are trying to display on the screen. So there we go. We've basically implemented the necessary functionality to be able to load in a PNG file into our game engine and use that data to actually apply textures onto objects within our scene. If you have any questions about this VMK or how to compile the PNG library, I recommend you first view the VMK number 24 in the C++ series. And if that doesn't answer your question, then head on down to the forums by clicking on the thread link beside the particular VMK that you have questions for and posting your questions there.